Hi everyone. Today machines are learning faster than us. While in this video, we don't intend to address this concern, but my intention is to help you learn how to make the machines learn. Whether you are driving innovation at a startup, leading a tech team for your business, or just curious about data science, and you must watch this video until the end. Also know that the AI revolution has already happened. And if you're watching this video, it's just that you are left behind. Today we will address the following questions: how to have a standard environment for machine learning in Python, which we can use over and over again to perform machine learning on any kind of data set. To keep your interest level hooked up, I'm going to use an interesting data set of Airbnb listings that you all are familiar with. The second question that we will address is how to sneak peek through your data using Python. Third, how to ensure data integrity while doing machine learning, and how to handle the missing values in our data set, and how to make the data ready for machine learning. Fourth, how do we prevent our model from merely memorizing the data and why that's important? Fifth is what's so hot about the hot encoder and how do we convert categorical data into a machine readable numerical format? Last but not the least, what are transformations and what do they do to our data to make it machine learning ready? Hope you will find value in this video. So let's go ahead and get started. So I have some core steps that everyone can follow and use my Python script to use it over and over again for any kind of machine learning setup. So let me first introduce you to our data set. Our data set is Airbnb listing. This is the Excel file. And let me introduce you to the columns that we have here. First is host. Is the host identity verified? Yes, no, 0, 1. Neighborhood, is that cleansed or not? Latitude of the location, longitude of the location, property type, if it's a house, apartment, condominium, what kind of room is it? Is it like entire home? Is it like private room, entire apartment? How many people it can accommodate? 4, 2, 3, 7, whatever. How many bathrooms it got? How many bedrooms it got? How many beds it got? Bed types, number of amenities it got, 14, 20 guests that are included. Can somebody bring guests? I think that's what it means. Price per extra person. Some Airbnb listing charge per extra person. Some of them don't. Minimum nights that you want to stay in that Airbnb. Number of reviews that a particular Airbnb listing has got. Number of days between first and last review. Some just make up the reviews by asking people in the beginning and they don't have any future reviews. So we're going to make sure that we cover that aspect in our database. Then review scores rating, how good are those reviews? Then what's the cancellation policy? Are they flexible? Are they moderate? Are they strict? They don't allow any cancellation. How does that affect on these three final target variables? Price greater than 150, or a price category. So this target variable is called a categorical target variable. Here it's called a binary target variable. Here the target variable is called a continuous or numerical target variable. So we got three different kinds of target variables, and we can include only one target variable at a time. All these are predictor variable. These all predict our target. These are all x's. These are all y's. But in a single machine learning program, only one target we have to choose, and we have to ignore other two. Just remember that. Finally, we are on the Python code. That's the setup that you guys can use over and over again. So first part is import numpy as np, import pandas as pd, and we have a random seed called 42. So that's just to get us started with. These are packages that are pretty important. Pandas and numpy, you can read more about them if you just simply select and Google them. You'll find plenty of information about these packages. NumPy documentation. So there's like a full numpy.org website we got here on Google. So there's tons and tons of information on NumPy packages. You got W3 schools, py.org, talking about NumPy. NumPy is a community-driven open source project developed by a diverse group of contributors. NumPy leadership has made a strong commitment in creating an open, inclusive positivity in the community. Please read the NumPy code of conduct. So you could simply install, if you don't have NumPy on your computer already, you could use this command, pip install NumPy. You could just copy it and paste it on your IDE. I'm using Jupyter Notebook. You could use whatever. So the next part is get the data. We will predict the median house value in the data set. So we first read our data. We call a variable. We just define the variable Airbnb. PD, we have Panda, PD representing the Panda package. Read CSV. So this function of Panda is able to read a CSV if it's in that correct folder where your ID is pointing to. So I use another command, airbnb.head, that only shows the first 5 rows, including the top header. So I'm able to kind of visualize or sneak peek in the data. What does it look like? How many columns it got? What kind of numbers these are? We don't. So in our case, I'm able to open the CSV, but a lot of times you won't be able to open the CSV because CSV got too large. Here is what the strength of Python is. It can open very large CSVs and it can show you that information with this modifier head. So find the total number of rows, Airbnb.shape. So we wanted to see the shape of Airbnb. Airbnb.shape, it shows me 3,555 rows and 23 columns here. So let's verify if it's giving me correct information or not. So if I go to the bottom of this sheet, 3,556, and this includes the header, the heading that is on the first row. And Python excludes that heading, this heading, and it counts rest of the rows. So now Airbnb ISNA is null. I'm checking the missing values in our database, which is a good practice. And I'm trying to see what all columns have how many missing values. So for example, bathroom column has 14 times or 14 rows that are missing. They don't have any kind of data. Those listings just don't show any kind of data. Bedrooms, like 10 of them are missing, 10 rows in the whole data set. They don't have any information about how many bedrooms this location has got. Similarly, we got review score rating, 800 locations. We don't have any information. So should we remove those rows or not? That's a question that you will learn in our future videos, whether to remove them or whether to impute them. So, but if you want, or if you decide to remove all those rows, which is totally fine, which is the cleanest way to do or handle the data set which do not have any kind of data, then this is the code. So what you would do is just run this, drop NA, and in place equals to true. And that would drop all those rows and make them zeros. But we are not doing that in our current, with our current data set, because we will follow a slightly different strategy. So split the data. I'm going to come back to this, how we handle this. Now, we have to split the data in test and train data. So let me tell you what I mean by that. So if this is my data set, I'm just going to draw something out here. So these are plenty of rows in my data set, first row, second row, and we keep going on. Let's say 100,000 row. So I got 100,000 row here. Then what do? How do we do a test, train, split? So what I would do is I would take some portion of the data and I separate that and I would call it as test, and rest of that data, I would call it as train. So this is my test, train, split. Typically, this is like 70, that's 70%. And this guy is like roughly 30%. There's no hard and fast rule what this needs to be, but typically this is very small compared to that being large. So the more data you train, The idea is the more data you train, your data should be able to predict the test data. Test data is where you are testing your machine learning, whether it trained properly or whether it did not train properly. So that in future, if your data set encounters a real life natural data the next time, for example, if it's like a next future Airbnb listing, so it will tell the customers or the Airbnb or make a suggestion that this Airbnb listing based on the parameters that you've put in is worth $200 based on the past learning. Again, remember, based on what I learned in the trained data set, it can predict this guy, and we test that. It's still going to predict this test part, but we have its utilization in the real world scenario where we want to see what's my home worth in an Airbnb listing. If I got 2 rooms, if it's in a downtown, what is it worth if I put that on Airbnb? $200 per night? That's the question we're trying to get at. But we got to test that data. The trainings that we do, we got to test it from the same data set. We split that data set in 30% and 70% set, and we test it whether it's performing well on the test set. If it is, then let's run it through the real world scenarios. So we do a 30% test set, and rest Python is able to understand that it goes in train set. So we split the data using a package called scikit-learn from sklearn. You may have to install scikit-learn package using pip install. If you are not able to, if you run into some problems, feel free to leave a comment. I would be happy to address that. From scikit-learn, model selection, import, train, test, split. So that's again a function that's already present in scikit-learn. Now train.shape. So we got a smaller data set now, and test.shape. So it's telling you the shape of the metrics. It got 1,000 rows. This got 2,400 rows. We previously had 3,500. So this 3,500 is now split in 2,400 and 1,000. But see that the column number remains the same. 23. The columns did not change. It's just the rows that got split, as I explained before. So the test header, first 5 rows, how do they look? It's just some data, and that test header, this was a train header, this is the test header. So they are just data sets for me. Now I'm going to use a new function called describe. So describe, I'm just trying to see what these numbers, just out of curiosity. Host is a super host. It got 2,488 rows, which was this number. It got 2,488 rows. And what's the mean? So 0.1. So average, it's just simply dividing by the total number of rows. It's a summation over total number of rows. That comes out to be 0.1. What's the standard deviation? 0.3. What's the 25% percentile? A maximum is the 1. So, but I know from past, looking at the data, I can show you again, this is just a binary column. So it won't have any other numbers other than 0 and 1. That would make any sense. So either it has this column as zeros or it has ones. Similarly, latitude, longitude, but where's exactly what's the maximum number of latitudes roughly around? I'm around 42 and 71. That's the maximum latitude I got. Was the minimum 42, 23. So I know the range of the location by these latitude and longitude where I'm talking about, and accommodations. And typically I have at least one accommodation, which goes up to 16. And you can see the bottom quartile, 25 percentile, 75 percentile. Most people have like 4 people that they could accommodate. Then let's jump on. That's just trying to see or sneak peeking into the data, how it looks and what kind of numbers it represents. Now, the next step is the 12th row has train is null sum. So I'm still trying to see what all nulls it got in just the train data set. So it still got 556 missing values, 10 bathrooms are missing, and 8 bedrooms are missing. Now, we're going to address this issue, but let's jump on to an important thing. Let's decide the target column. So these are my target columns: price greater than 150, or price category. I'm going to show you this again. Price price greater than 150, and price category. I'm going to remove these columns altogether from the train data set. So that they could be part of the target variable. So I'm just uh, train target. So I call this new variable called train target, train. So it got all three final target variables, price greater than 150, and price category in the single variable called train target. The other new variable is called train numeric columns. These are all columns with just numbers, no category, no alphabetical data in it. Latitude, longitude, accommodates. These all are numbers. Train binary columns. I make a new column here called train binary columns. I use the full train data set and pick two columns out of it. Host is superhost and host identity verified. Yes or no? So these are binary columns. Host is superhost. So one of them is host identify verified, identity verified, yes or no, or host is superhost. So this again is a binary column. So these two columns we're going to put in a new variable called binary columns. In the last part, train categorical columns. To train, so all those columns which have alphabetical stuff, alphabets in it, that's neighborhood cleansed, property type, room type, bed type, cancellation policy. So these are all categorical columns. So I put all these guys in a single variable called train categorical columns. Now train numerical columns head. So numeric columns, it just shows you that all of them are just numbers. We still have those NaNs or missing values, which we observed here. Then train binary columns. So this binary column guy is now, we are just seeing the header, the first few rows of it. So these are just zeros and ones. These are binary in nature. Train categorical columns. These are all those columns which had letter or alphabetical information in them. Process the numerical variables. So how do we handle the numerical ones? So I showed you what I did here. Now I'm going to show you the next step, which is the simple imputer. The step is called imputation. We are trying to get rid of the missing values. You could just simply choose to delete those missing values from this using this statement, train drop NA. So you would get rid of all the missing values from the train data set. But I'm going to choose to impute. Impute means like putting something in place of the missing values. So I'm using a simple imputer, and the strategy is median. You could choose a different strategy, by the way. You could use multiple strategies. Here's a simple imputer function in Python. Here, I just Google it. The scikit-learn.org website provides all those functions of scikit-learn module or method that you got here. So other things that you could do, you could use a mean, you could do a median, you could do the most frequent, you could do a constant. So what it does is it puts, for example, for my case, it puts a median. So it's going to put these values, the median value, does it show, it can, so I'm showing mean here. I could use, so wherever the missing value or blank space is, it will put, if I define it to be a mean, it will put this value there. If I define it to be a median, it will just compute the median and replace all those empty spots with the median value of that column. That's the work of the imputer. So, or we could choose to make it like the most frequent, the most popular number. I think some people call it mode. So it could even replace it with the mode or just any constant. So you could choose a strategy based on your refined understanding of machine learning and what you're trying to target. Now, train numeric columns imputed. So what I'm doing here is I'm just using a fit transform. Imputed.fit transform, I'm putting into a new variable called imputed numeric columns. So by the way, what does fit transform do? Let's try to see what does this guy do and what it really means. So let me bring the PowerPoint slide on this screen. So here's what fit transform would do for you. So fit transform, so for example, you have the data set which has size of the car, compact, mid-size, color, white, red, black, price 22,000, 22,750, 25,000. When you do a fit transform, what it does is it computes the mean and standard deviation and puts your target variable. It works on the target variable primarily. So it translates your target variable to in the form of standard deviation. So the standard deviation is 1275, and this guy is 22,000. So what it does is 22,000 is, so mean is 23,250, which is 1275 away from 22,000, which in other words means roughly one standard deviation away. So less negative 0.98, roughly one standard deviation away from the mean. This guy 22,750 is 0.39 standard deviation away from the mean. This guy 25,000 is ahead by 1.37 standard deviation from 23,250, which is the mean. So that's called fit transform. We're going to see what simply transform means, but that's the next coming up. So imputer.fit transform, it does the transformation and puts it into the form of standard deviation. That's fit transform. How it looks after being imputed. So that's how it looks. It's just those numbers in there. Now these all numbers are in the form of standard deviations. See, 4, 2, 3, 5, which was previously 42. These are pretty heavy duty numbers. Now, if you observe that we don't have the header in this, so we're going to standardize the values. We're going to import a standard scalar. We're going to scale our numbers. Scalar.fit transform, you already saw what fit transform does for you. It further did a standard deviation and deviation from the mean, and it scaled it further down. So that's what you see train in this variable train numeric column standard, which is what we created here. We put like a scalar fit transform. Previously, we used the imputer.fit transform. Now we are using a scalar.fit transform to standardize the values. Now we convert back. So we don't have the header here. We convert them into form of panda so we can work with them. So panda.data frame, we put that in the form of a data frame. So we just use df as the name of our variable so that we know it's a data frame for future purposes. Now we put all that information, all this information, train numeric column standard, train numeric column standard into this standard underscore df so that it becomes a data frame. Now we see how it looks. So latitudes are now 0.82, 0.5, which was previously 42, 71. So see how it's got scaled down. Then what we do here is I just use the same variable isna.sum is null. I'm trying to take the sum of those columns if there's any missing values. So it shows me all zeros. So all the columns have no missing values. And that means our imputer function worked successfully. Just remember that once we use the imputer, we scaled it down to deviation from the mean format. Now we process the categorical variables. Until now, we just worked on the numerical variables. We got to work on the categorical variables next. So train categorical variables, we still got two null values. So is null. So that's the sum, is null.sum. That's what we are checking here. Train categorical columns, property type. So I'm just looking at the value counts here. Now find the rows that have missing values. So these are the two rows that got some missing values. You see NaNs here. So what do we do now? How to impute or work with the categorical values? We don't want NaNs in our rows. What we're going to do is use a different strategy called constant, and we will fill the unknowns, fill the empty values, the nans, with a word called unknown. So now that becomes another category. Unknown becomes another category. So this category is now being defined, simple imputer, constant. Constant is a strategy. What's that constant? It's just a letter called unknown, like a word called unknown. And that's the strategy that we use here. So we use the fit transform again and put all that information using the categorical imputer. So categorical imputer is the variable that we define or the function that we defined. And this categorical imputer would do like a constant replacement of nans with the word called unknown. So now we convert them back to pandas just like we did previously. And we try to see all those columns, how many data values we got here. And we got rid of the nan value, and we got another new column called unknown, which occurs 2 times in the data set now. Now it's time for one hot encoding. So one hot encoding. What do we know about this? Let's take a look at a simple example. One hot encoding converts this color column, white, red, and black, to zeros and ones. It divides this white, red, and black into three different columns, white, red, and black, and puts one only at the location where white is white, red is in the red column, other two guys become zero, and finally, the black is 1 in the third column, and white and red are 0. So this part, these three columns, is the work of one hot encoder, converting a categorical variable, white, red, and black, to zeros and ones, putting ones only in the locations where that variable is true, and other columns are converted to zeros. So what's happened here is categorical variable, which is made of word, white, red, black, is now converted into numerical columns, zeros and ones. See the magic? That's the work of a function called one hot encoder. There are other kinds of encoder, but let's start with understanding one hot encoder's work. Now, we are back to the screen where we were working with one hot encoder. One hot encoder's instance is created into a new variable called categorical encoder. They are the exact same thing. Cat encoder is just the name of the instance of one hot encoder. And I'm using cat encoder with a modifier called fit transform on train dataset, train categorical columns, which were previously imputed. Okay, let's try to understand what's this fit transform doing here. Fit transform works on the target variable. Here, in this example, it's price. Price, it becomes 22,000 becomes 0.98, 22,750 becomes 0.39, 25,000 becomes 1.37. Are you wondering how this magic really happened? It's with the help of these two guys, mean and standard deviation. So what's this mean doing? So mean is the mean of these three numbers, 22,000, 22,750, 25,000. Mean comes out to be 23,250. That's your train data set. Remember, train data set. In this code, we have this as train data set. We got the mean here. We don't do this explicitly. It's this function fit transform that calculates the mean of the train target variable, that is price in this example. In our example, it could be something else, but we got the mean again, mean here, and standard deviation, 1275. And with the help of mean and standard deviation, we calculate the final target variable in the form of mean and standard deviation. Actually, in the form of just the standard deviation. How far is 22,000 away from mean, 23,250, in terms of standard deviation? It's exactly 0.98 standard deviations less than the mean. Second guy, 22,750, is exactly 0.39 standard deviation less than the mean. Third guy, 25,000, it's more than 23,000, and it's exactly 1.37 times higher than the mean. So now we have an understanding of what's the purpose of fit transform. So this is that function which is doing the magic at the target variable. So we understood until this point. Now what we want to do, so we converted all these columns, all these categorical columns. Remember, these are just the categorical columns that we are working with, into zeros and ones. But now these zeros and ones were like a sparse matrix in the previous code. What I'm doing here is converting them to an array so that I could work with them better. So I'm just simply using a function dot to array, open close bracket, represents a function or method in Python. Now I'm simply printing out cat encoder. What's cat encoder? Cat encoder is this guy, which is the instance of one hot encoder, and I'm printing the categories that it has. So remember, I converted this to an array, and now the array So the categories are now in the form of array. These are just the header. Header means all the different categories each column has. So the first column has these categories. What I mean by that is if I look at my data set, this is my categorical column, and the name of this categorical column was neighborhood cleansed. So it has a category called Rosendale. It has category called Jamaica Plain. Do I have these here? Jamaica Plain. Do I have Rosendale here? Let me see, Rosendale, this guy here. So I got these categories. This is an array made of categories out of this column. Similarly, I got so many more columns, and embedded or the members of the array are the categories in those columns. So these are data type is object. And what are we going to do now? Let's flatten the array of arrays to get the column names. So in the sublist, categorical cat encoder dot categories, which has all this stuff here, we're going to pick each item out of them from the sublist, the larger sublist. It's just these 1, 2, 3, 4, 5. So these are 5 columns forming first sublist. So that's going to be the output of this guy. Oh, there are 5 columns as sublist. So each column, first this guy, second that guy, third this guy, fourth this guy, fifth this guy, will be sent out one by this piece of code for item and sublist, because this is the larger sublist. Now, inside that sublist, we want to separate out each column individually. For sublist in this sublist, that means for each of these guys, for sublist in this sublist, that means Alston, Black Bay, Bay Village, Beacon Hill, Brighton, and so on. And in second sublist, apartment, bed, breakfast, and in third sublist, and in fourth sublist, and in fifth sublist, flexible, moderate, strict, all these individual objects are now a column by themselves. That is called converting the categorical variables into numerical columns. So we put all the output of this function or this for loop into one hot column names variable, and I print that out, which is all those variables, all those objects printed out. Now those are just the objects. I want them into Panda data frame. So what I do, I put that columns, one hot column names that I just printed above, this guy one hot column names, into columns. I just reset the index. What does that mean? Index for my data frame is going to begin with 0, 1, 2, 3, 4. That's the index that does not have a header because that's an index. And I put all this, the output of this, all these columns into a Panda data frame, which is now called train categorical columns one hot data frame, or DF. And I just try to print the header of that. And you see all those columns, all these guys, this stuff are column by themselves. And you see these 3 dots, it indicates all those columns, which are not shown in this, but it contains all the columns. So we are just printing the header here, and we have kind of compressed it, the header here. Now, we just worked on the categorical. What about the binary? We don't process the binary variables because they're already in the numerical format. Now, what do? We have a separate data frame of categorical variables converted into this numerical format. And we got the binary variables, and we got the variables which are previously or originally numerical in nature. We concat them. We concat these guys and make a single large data frame. We use command or Python code called Panda or PD. That's the instance of Panda. Panda.connect. And I concat all these 3 guys. Train numeric columns, train categorical columns, train binary columns. And this forms a single large train data set. Train.shape is 24,088 rows and 66 columns. So these are 66 columns here. And now each of these columns, you could see latitude, longitude, they were previously numerical in nature. I put numeric first, so numeric gets combined with categorical next. So all these zeros and ones that you observe are now the categorical converted to numerical. Not all of them are shown here because it used 3 dots to compress the output. And finally, the binary, the ones that were originally binary or zeros or ones, that is host is superhost or host is, does the host have a verified identity? So these zeros and ones in the last 2 columns that we see. Now we have prepared the train data set. Train data set means the data set that we use to train our model. Now what's transform? Now process the test data set using transform or transformation. We're going to work similarly, exact same way on the test data set with a minor nuance. So let's dive in and try to understand what's that minor nuance and how to prepare the test data set. The test data set has potential test categories as price greater than 150, price category. Note that at any given point of time or in any given model, I'm simply going to use only one target variable, either price or price greater than 150 or a price category. I won't be using all 3 at the same time. Right now, I'm simply indicating for the purpose of data preparation that we have potentially 3 target variables in our data set. So again, I'm following the same process that we did before. Test data set has the exact same columns, latitude, longitude, accommodates bathrooms, bedrooms, etc., which were previously numerical. So I call them numeric columns. Unlike before, where I used the word train, now I'm using the word test. Test numeric columns. Simply, my data set is divided in 2 parts, test and train. So let me try to help you visualize what I mean by that. So imagine this is my full data set. I divided this full data set in 2 parts. This part is 70%, and this small part is just 30%. Now, note that I have the exact same columns though. So column name for test and train data set will be exact same. They will have no difference whatsoever at all. And that's what we were doing on the screen or the Python environment right behind it. So the target variable, when I use the word target variable, is the last column. So these potential 3 columns, one of them I'm going to make my target variable based on my needs. And all of these are predictor variables or the variables that help me predict the target. So help me predict the target. So all these column names, so whatever these column names are, I'm simply going to use the same column names for both test data. So this part is the train data, which is 70%, and that part is the test data, which is 30%. So for test and train, these column names are going to be exact same to predict the exact same column. But know that this software reads to understand what all this is, and this part, this part of the target variable, we test the learnings from this train part and try to see if it's able to predict the target variable in the test part. That's why it's called test. So we are testing the learnings. Like if you are a student, we test your learnings in the exam. That's the exam of the machine learning model. So we have exact same column names, but with a slight nuance. One of the slight nuances test instead of train in the variable names. Now we use the simple imputer, imputer is the instance of the simple imputer, which uses the functionality of median imputation for our purpose. You could use something else, you could use the most frequent or whatsoever as we discussed before. So we are doing the same imputation at all those locations which were not defined before. So we are using the imputer in the test part of the code. Now we are standardizing those values. We are using scalar, transform. So we use the same standard deviation method. So we take the standard deviation of this, we get the mean of this array and try to see how far are we or each of these guys away from the mean. So it's 1.212 standard deviations away from the mean. So all these are numeric columns that we are talking about here. So we did this imputation and we scaled or standardized our values. Now we're converting them back to pandas just like we did before. So pd.data frame and the columns are test numeric columns. And all this is going in standard test numeric columns standard underscore df, and we are showing only the header. So this is the header. So all these numeric columns are now scaled. These are not the original numbers. These are the scale numbers that we see here, and they are in the form of standard deviation. Now, since we have imputed, we try to see and sum up any missing values, and the sum comes out to be 0. So now we look at the categorical variables. So in the categorical variables, there still is an A at one location property type. So we're going to do some imputation here with a word called unknown for the categorical variables, just like we did in the train data set. Now we are working on test data set. So we use the categorical imputer, which we defined before. And I'm simply using the instance of that definition. And I'm using the transform and imputing the categorical variable with the word unknown wherever the missing value was. Now that makes itself into a new category, and I'm converting them back to pandas. It's the same routine process that we discussed for the train dataset. And here are my categories. Now see, there's unknown as a separate category, and I'm going to use the same one-hot encoding, cat encoder.transform. Note that when we first tried to use the one-hot encoder in the train dataset, I used a fit transform function when it was train dataset, train train. Now, when I'm trying to use the one-hot encoder in the test dataset for the same categorical variable, I'm not using the fit transform. I'm simply using the transform command or transform. What's the difference? Let's look at a simple example here. The difference is fit transform calculates the mean and standard deviation, and on that basis, it calculates the final target variable, how far the target variable is away from the mean and standard deviation. But we don't want that to be done for the test data set. That's the nuance I was talking about. So this is incorrect. I'm not supposed to be calculating a new mean and standard deviation. So this is the test data set. This part is a test in this current example. I'm not supposed to be calculating a new mean and standard deviation for the test. I'm supposed to be using the previous mean, 23,250, not 46,000. 1275, yes, and not 2944. I'm not supposed to be using the new mean and standard deviation for the test data set. I'm supposed to be using the old mean and standard deviation, which was previously defined for the train data set. So for the one that we defined for the train data set is now being used for on the test data set. That's the learning we are using from the train to the test. And based on this, I'm defining my target variable, which is price. So this is my target variable, 15, 17, 20. So I'm 15, 17, and 20 times or 10, 20 standard deviations away from the mean, from the train mean, not the test mean. This test mean and test standard deviation has no value for me because I'm using the learnings from the model, not redefining a new model. So I hope you got the point that I'm trying to make. So in the test data set, I'm using the transform. In the train data set, I'm using the fit transform. I hope you got the point. If you did not, feel free to leave me a comment. I would be more than happy to help you more. So the rest of the process is very similar. I'm using the simple imputer.transform and converting them back to pandas and trying to see what the imputed column looks like. So I have this imputed column. Unknown is one of the categories. And I'm using the same one-hot encoder here, one-hot encoding. It's doing the same encoding from the test data set, but using the transform function, not the fit transform, converting them to arrays just like we did before. One-hot columns, how do they look? In the test data set, they're the exact same columns that we had in the train data set. Now I'm converting them back to pandas. So panda, you see how it looks, how nice it looks. So all these columns are now added to these column headers. So all these zeros and ones now I have the test data set that is now prepared, but we still got to join them or concatenate the numeric, the categorical, and the binary, which I'm doing here, and resetting the index. I'm going to see how the final test data set looks. That's how it looks. These are not the original numbers. These are scale numbers, or these are numbers that are in the form of standard deviations. So this is my final output of the test data set. We have not touched machine learning yet, but what we have done so far is find out how to prepare or learn how to prepare the data set, the test data set and the train data set using Python. And I've been using Jupyter Notebook, which is pretty intuitive. You could use some other fancy software. You could use Visual Studio as well. That's more than acceptable. You could use simple Python IDE in Linux, Cygwin. There are plenty of options, but this has been lately my first choice because it's intuitive, easy to explain. But I hope you got the point. I have my data set prepared, the test data set. I have my train data set prepared. That's my train data set. So I have got both of my data set that I'm going to use for machine learning purposes in the next video. Hope you stick with me and don't forget to subscribe my channel.